The third video for the 7.2b lesson. We're going to now define a quadratic function. So this equation that was provided and will be provided, and we'll kind of get a sense of what these problems are about once we start looking at example problems. This first one was more of like an intro problem, but this was a quadratic function. A quadratic function is a function that can be described by the equation in this form. So it almost looks like absolute value. The one that we were using up here was maybe not exactly looking in this form, but for the most part it is. The requirement for something to be called quadratic is that the power of the variable needs to be 2 for the x variable, the independent variable. If it was 1, it would be linear. And so this one had that as well as this one does. You'll also notice that this, which we're going to use throughout this lesson, you might want to copy this down, has some of the same variables that we had with absolute value graphs. So we're going to think about, will A, H, and K behave the same way that they did with absolute value graphs? But notice that it does not have absolute value bars and it has squaring. So making some of these tables and number crunching these might be a bit trickier. The actual graph of a quadratic is called a parabola. It's going to give us a curve. And a real world application is anything that's being acted upon by gravity. So, throwing an object such as a ball or a football, or even just dropping an object. We can describe that in math and science and physics with a quadratic function or with a function that has an exponent 2. So, we're going to look at our first graph, our parent function y equals x squared, the most basic one, and then we will start to modify this. I'm going to do some hand work or scratch work over here, and I would suggest doing the same. And in this table, I added a few extra points, but we'll start with the ones here, and then we'll go back to the other one. So 2 squared, this would be y equals our input. Technically needs to have parentheses around it. One squared is 1. Zero squared, 0. -1. So we need parentheses hugging the -1, separating the -1 from the 2. -1 squared is 1. And -2 squared is 4. -2 times -2 is 4. All right, so we're going to go in now and enter this into this table. And we'll also fill in 3, just so we get a better sketch of this. And we had this table has negatives up at the top, but we can adjust that and fill these in. And 3 squared is 9, and -3 squared is 9 as well. So we start to see what might happen with some of these tables. And then we're going to sketch this. So this really, again, you want to try to curve it. It's going to be a bit tricky. You can't use the line segment tool. It should not be made up of line segments. So we're looking for a graph like this. That's a nice bowl. If you want to open up a Desmos blank graph to graph one in there and see it, feel free to do so. But with a pencil or with a stylus, whenever you're doing these on paper in your homework or on the screen, you're doing the best you can to make it rounded at the bottom. So it really should be like a U and not like a V. The V was what we had with absolute value graphs. All right, so there's our first quadratic function, the parent function, which we'll use as a reference as we start to explore modifying this function and its graph, which is known as the parabola.